order to find the zeros of a function. They allow you to find the x-intercepts of the graph if they are real zeros. So this first slide you don't need to write down, but I just want to talk through it. If you want to read it on your own and pause it, what we're looking for is if here is my quadratic function, the zeros are when this function equals 0. They are also going to be your x-intercepts. So when you hear the word the zero of the function, they are your x-intercepts. How you find this is you set the function equal to 0 and you solve for x. And a lot of times you're going to factor, 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 factor. And in a quadratic equation there's going to be up to 2 roots. Roots are the same thing as zeros. And one of the important things here, you can find the zeros of a quadratic equation by factoring and applying the zero product property. So let's go on to our first example. Here's an example. We have a quadratic function, f of x equals x squared plus 2x minus 3. And we want to find the roots or the zeros of the function, which will then be our x-intercepts. So we're going to set this function equal to 0. So this is going to be replaced with a 0. So 0 equals x squared plus 2x minus 3. Now we're going to factor it. If you remember the rules of factoring with the trinomial, we made a chart. And we say, what are the factors of c? So we're going to factor negative 3 that add to b. So what adds to 2? So we say, what are the factors of negative 3? Well, negative 3 times 1 or negative 1 times 3. When we add them, negative 3 plus 1 is negative 2. Negative 1 plus 3 is 2. The one we want is the one that adds to 2, which is this one. So these are the numbers we're going to work with right here. So we're going to split up this quadratic equation into 2 factors. Split up the x squared into x, and then minus 1 and plus 3. Now it's completely factored. We're going to set that factor equation. So I kind of did step 1 and 2 together. We're going to set each factor equal to 0 and solve for x. So this is considered a factor. And then this is considered a factor. And we solve them for x. So we solve by undoing. So we're going to add 1 to both sides. And we get x equals 1. So one of the zeros is at x equals 1. Then this one we subtract 3. We get x equals negative 3. So we have 2 zeros of the function at x equals 1 and x equals negative 3.